Hey everyone. So in this little short clip, we're going to look at investigating left and right-sided limits. Here we have an example where we have a graph of f of x, and we're going to look at how to evaluate limits as we approach them from different points. So let's start at the very left here with the limit as x goes towards -2 of f of x. Okay, so we see the limit as x goes to -2, we know this would be the -2, and we see both from the left side and the right side, because it's an overall limit, it approaches the same value there, despite having a hole, and that value seems like it's 3.5. So therefore, the limit as x approaches -2 of f of x is equal to 3.5. Now the next one, if we look at the limit as x approaches a -5 minus, and remember this negative in the exponent there means from the left, right? We see that we just follow the line from the left, and we know this is going to be -5, and we see it has a value of about, looks like 2, right? So we say the limit as x approaches -5 is going to be 2. As x approaches -5 from the left is going to be 2. Now the limit as x approaches -5 from the right, and how do we know it's from the right? Because of this plus symbol, sort of in the exponent spot of that -5. We follow the graph and we see the graph is approaching, what is that? -3. So this is how we deal with our left and right-sided limits. Now, we know that for a limit to exist overall, when we look at the last example here, the left and right-sided limits have to be equal. So if we look at our limit as f of x, or of f of x as it goes towards -5, we see one of the limits is approaching from the left, and then the other limit that approaching from the right, their values are not the same. So therefore, this one would be DNE, or does not exist, and that's because BC, the limit as x approaches -5 minus does not equal the limit as x approaches -5 plus.